welcome everyone to today's ALASCA Tech Talk. It's ALASCA Tech Talk number 23 already. For those who don't know me, my name is Ariane. I'm the community manager of ALASCA. And if you haven't been here, this format, the ALASCA Tech Talks, was established by the ALASCA Association. And this is a monthly meeting where we just come together to talk about everything related to open source technologies in the area of cloud and cloud infrastructures. So any new ideas, new developments, whatever there is, we are happy to discuss here. Also, please note that this session will be recorded. We are uploading this on YouTube later. And I've already had people ask me if this is being recorded today because they really want to look at it, have a look at it later. So yeah, please keep that in mind. And let me see. Okay, let's have a brief look at the agenda. Nothing new. We will dive right into today's Tech Talk and have plenty of time for discussion afterwards. Then we will look at some news and events, things that have been going on in the ALASCA community and are about to come in the future. And then we will also announce the next Tech Talk for April. Okay, so today we are here to hear about to be exploring the rewrite of OpenStack Keystone in Rust. We have Artem Goncharov here. Welcome, it's good to have you. He's the Keystone Project Team Lead. And I think with that, I'm already ready to hand the stage over to you. And you can start with your tech talk.
Thank you very much, Ariane. Starting screen share. You see my screen now, right?
Yes.
Perfect. Thank you. Okay. Hi, everybody. For those of you who don't know me, my name is Artem, and I'm going to be talking today about idea and findings, actually, of rewriting Keystone in Rust. I'm currently, as already mentioned, project team lead of OpenStack Keystone. Therefore, I claim to know at least a little bit of what I'm talking, not that I'm talking something completely insane. So, short agenda. I'm going to have a few explanatory blah slides, trying to describe what I was working on, how actually I came to idea, how the idea was conceived in my head of rewriting that. Followed by actually describing how the Keystone library can be built or why is it necessary. And then we are going to look at what it cost actually to add API on top of the library for Keystone. Then, last but not least, maybe the most interesting part, I don't know whether the performance slides or demo are the most interesting things, but we are going to have a look on some performance benchmarks of Python Keystone implementation versus Rust Keystone implementation. Then we are going to have a short demo, and I hope the demo gods will not curse me today. But yeah, let's see. And the way forward, where I will try to describe in general next steps, at least that are currently in my head, of what can be done, what should be done, and what the strategy actually is. So hopefully everyone is ready. So let's go on. And I think I need to close a little bit. Okay, so the pop-up is gone. So what I was working on. In the last couple of years, I was working with and for different CSPs, and actually was mostly working on the point of improving federation support of Keystone, where users or CSP customers are currently not being able to manage their own federation configuration, like managing their own OIDC connectors or LDAP or similar without actually involving administrators. As you know, most likely in Keystone, you need to be admin to actually manage those federation stuff. The federation in Keystone is actually managed directly outside of the Keystone. So it's not the Keystone itself that manages this federation. It's actually delegated to Modal's OIDC module of Apache or a similar module of Nginx. And that actually limits some integration capabilities. For example, if we are looking at backend initiated logouts features or similar stuff. So there are much more things that are simply not possible to be implemented just because this integration is not within the Keystone itself. For the customers, it's actually also not trivially possible to reuse a single IDP while having control of this integration. What I mean here is that imagine you have a GitHub authentication in Keystone, and you want, or actually one of your customers want to have requirements that all members needs to be members of, all users must be member of certain organization, while other customer would of course want that their users must be member of different organizations, and eventually in addition to that they must be member of a certain team. So that's actually, while still technically you have a single IDP, the requirements by different domains are completely different, and there is no possibility at the moment in Keystone to implement that. Next thing is that actually when you do any modifications on IDC federation, that requires a restart of Keystone, which is actually causing a downtime, which is most likely not what you really want. There are some ways how to avoid that, but depending on the style of deployment, this actually is not possible to be avoided. Then at the moment, we do not have any support for scheme inside of Keystone, inside of OpenStack in general like that. And scheme stands for System for Cross-Domain Identity Management. This is for those of you who do not know. This goes hand in hand with OIDC itself, where OIDC as a protocol is taking care about authentication, and scheme is taking care about user data synchronization, so that before the user even tries to log in, his data is already synchronized and available on the target platform. Then what I was working on, at least the idea that I was working on, is to have possibility to exchange JVT for an OpenStack token. I'm going to be talking a little bit more about that a bit later, but roughly the idea is, imagine you have a GitHub workflow within actions, and typically with for all the other hyperscalers, there is possibility to exchange the JVT that was issued by GitHub as a trusted IDP, and you can normally exchange it for the platform token for your cloud token, for like a session token. But this is at the moment not possible for OpenStack. But in reality, what I'm working on is exactly to have this possibility, so that we can bring OpenStack one step closer to be competitive with hyperscalers. Then there are some issues regarding fine granular access control, where at the moment, in OpenStack, there are just few roles, and typically customers want to have more control on that, more fine granular roles. And this immediately brings you in the problem of role explosion, which is a very common problem for airbag concept. Those CSPs that are typically not offering only OpenStack, but in addition to that, some other services like Kubernetes on top of OpenStack, or database as a service, or backup as a service on top of OpenStack, they typically try to join multiple different platforms, and they would normally have a single place where they manage authorizations. At the moment in OpenStack, there is no possibility to actually overtake authorization for other services, like integrate other services into OpenStack. And as well, it is not easily possible to delegate authorization decisions out of OpenStack to external system. Well, it would be possible in few slides later, but that's generally what I was working on. And then lack of service accounts concept. So working on those, I actually came exactly to the idea. So what if we would write a Keystone library, or in Rust, for Rust, in Rust, doesn't really matter, and basically make it take care of exactly those additional things that I just mentioned. Why do we want to do something like that? Authentication and authorizations are actually incredibly complex things. Those are not a single step process, but those are normally actually multiple step processes with plenty of configurable and expected deviations from the standard, or actually part of the standard. There are multiple workflows, and implementing all of those different capabilities is incredibly complex. I was, honestly speaking, really struggling to find any Python library for OIDC and scheme that would be actually able to solve all of the requirements, all of those requirements. Yeah, some of them are simply not OCI compliant, so that means that we are not able to pull them into OpenStack. Some of the libraries are actually, you see, they are not really very well maintained, and you see the history that the library is being unmaintained, and every couple of years a new attempt to revive it starts, and then in 1 year again it's being like abandoned and starts searching for new maintainers. And last but not least, here it's important really to mention that implementing those federation-related stuff in Keystone requires you to implement in OIDC, it's called relying party. And that actually on its own requires that you need to implement both being IDP and being a client at the same time, because you are like man in the middle and needing to be doing lots of different things. And I wasn't able to find any single Python library that is capable to actually do all those things together. So again, I thought that it would make sense to create like a library for Keystone, like an external component, or maybe you can name it as a Keystone extension that serves all those needs and that CSPs are able to deploy on their system in parallel to existing OpenStack. Why is that? Actually, in the real wild world, I have seen plenty of CSPs running relatively old versions of OpenStack, some for the reason, some without reason. So in the majority of those are simply struggling to get the latest OpenStack version. And so I was thinking that if we would invest time and bring those features into upstream in the sense of really into getting them only in the newest OpenStack release, majority of the CSPs would be simply not capable of starting using those features. And when we have this as an additional external component, it would be possible actually to deploy it with nearly ancient version of OpenStack, and it would be just working perfectly fine. Then one thing about Rust or not Rust. Well, I mentioned already lack of Python libraries, but in addition to that, there is already, some of you may know, there is SDK CLI 2 for OpenStack that I'm generating from OpenAPI. And what I was thinking here is that it would make really very much sense to actually integrate this into this new library to be, for example, proxying requests to native Python Keystone in case we would want to actually deploy this external component or actually extend this component to be entry point for all the OpenStack requests. And if the request can be served inside of this component, then it's served inside. Otherwise, it can be simply proxied to the real Keystone. And that is where basically the SDK would be really very helpful. So we come to the point where library for Keystone, sort of library for Keystone is necessary. And here comes the fun point. Issuing a token actually requires you to support nearly half of all OpenStack, of all Keystone managed resources. So you need to be dealing with projects, domains, users, groups, roles, role assignments, role inference, catalog, and stuff like that. Ethernet token decryption, encryption. So just to be able to issue token, you need to support half of Keystone. And then, of course, direct access to a Keystone database is also not unavoidable, because we would need to persist new resources for the federation. So technically, what we need is CRUD for resource provider. Resource provider is the one that is dealing with domains and projects. Identity provider, the one that is dealing with users and groups. Assignments provider, the one that is dealing with roles, role assignments, role inference. Catalog provider, and here I explicitly said that mostly actually only read operations on it would be required, but still catalog provider must be also implemented. Pernet, we need to be able to decrypt and encrypt token. Message pack, well, actually, for those of you, and I would assume majority don't know that in reality, Pernet token is just encryption of another binary protocol that is packing the data inside. So it's not simply Fernet token. Fernet is used just for encrypting, and underneath it is message pack payload that we also need to be able to encode and decode. And here we would also need not only to be able to issue a new token, we would need to be actually accepting token issued by real Keystone. So we need to have this compatibility between Rust and Keystone, and they both need to trust to be able to really actually verify an issue token that would be accepted by the other part. Once that is actually done, adding an API on top of that, on top of the library, is actually just peanuts. So technically, what needs to be done is token validation. We need to be able to validate the token that was presented by the user. If we are not talking about authorization or authentication, but we are talking about the request came for like managing federation resource, and we would need to verify that the token was issued. That the token is valid. We need to be dealing with policy. Honestly speaking, this is not done yet. And also here, important to mention, I'm not planning to re-implement Oslo policy in Rust. I'm really not even thinking about doing that, because there is Open Policy Agent stuff that is definitely much more flexible, giving you much more possibilities. And there is another project of mine where I'm actually offering a way how to convert Oslo policy-based policies into Open Policy Agent language. And with Oslo Policy plugin, it is then possible to actually delegate authorization decision to Open Policy Agent. And it actually can be done also with nearly any version of OpenStack. So technically, that is exactly the thing that I mentioned in the beginning, that we have possibility with that also to delegate authorization decision, not authentication, but authorization decisions outside of OpenStack. And they have a single platform based on the Open Policy Agent where you integrate also your other offerings. But yeah, anyway, that's not part of the talk. It just, I'm not going to be dealing with re-implementing Oslo policy in Rust, but instead I would directly be implementing delegation of the authorization decision to Open Policy Agent. So after that, we actually need to do just a few remaining steps. Convert the API request from the API structure into the structure that is expected by the backend or the provider, invoke this provider method, and then convert the response back as an API response and send it back to the user. I wouldn't claim, of course, that this is just few lines of code, but this is incredibly easy. The most complex part is actually implementing the backend itself. But I mean, if the backend is there, making an API out of that is actually just nothing. That would be very complex. Now let's have a look at performance. I'm explicitly talking about performance before doing demo, because I think this is the most intriguing part, at least for me. And I would like to keep interest, or maybe to raise interest of people. A few facts on that. So to just to clarify expectations, password hashing is slow, and is slow on purpose. all the password hashing methods were designed to be slow on any platform. So what I mean here, do not expect that simply re-implementing Python, replacing Python with Rust, you will get any performance improvement for those operations that are dealing with password hashing. And yeah, password hashing is also involved in simply authenticating with the password. So if we here replace Python with Rust, do not expect any performance improvement on its own. But there is performance improvement, I promise. That's definitely there. Just to have a look also on some performance figures, let's start really from the very root of the Keystone related functionality is decrypting a token. What you see on the screen is just a really very tiny benchmark test that is simply invoking Python method or Keystone method of validating the token. I admit here completely the name is incredibly confusing. This validation has nothing to do in reality with validation. It just decrypts the token, it unpacks the payload and verifies that the token is not expired or expired, and also doing some additional like configuration mapping. So it doesn't really check whether the token was revoked, is not trying to resolve the user. So it just more or less only dealing with the payload. And here are the results. The test on Python, on the Linux, and we would be talking about that in a minute, but if we are talking about the performance on Linux on Intel device, this test above is taking 200 microseconds, and the same test on Mac device is taking just 70 microseconds. Please don't ask me to explain why is that. I was also incredibly interested about that. I would be, honestly speaking, even keen to explore further whether this is really just Mac optimization or it's simply based on ARM device, that ARM architecture is capable to do certain things that are invoked here better. Because actually I haven't seen major difference between Intel and AMD. They are relatively comparable, while Intel AMD versus Mac is always, there is a big difference independent on which operation we are talking about. But anyway, you see here some rough numbers. It's 70 microseconds in Mac and 200 microseconds on Linux. And let's now have a look at the same functionality, literally just absolutely the same functionality in Rust on Linux, again, on Intel or AMD device. It takes just 8 to 9 microseconds, and on Mac, just 3 microseconds. So here we see roughly, actually, it's relatively similar improvements independent on the platform of like factor 25. And we are at the moment talking only about token decryption. So in my eyes, this is really a very interesting number that you can start with. Next step, I tried to actually have a look on a more complete use case, and I have implemented the operation get users operation both. Well, I implemented get users operation also in Rust. So for the beginning, we are looking at load test that I was doing for that operation with the Python one in my sandbox. And that means that technically I'm having a developer environment on my laptop with a local database, with the Keystone running as a process under UVSGI. So we see here the average latency of around 600 milliseconds for the operation. Don't take it as an absolute number. In all of the tests, we are not really looking at absolute numbers. We are only looking at improvements, because as you have seen, there is a huge difference in absolute numbers between different platforms. So it's not useful to compare them. So anyway, We have a average latency of 600 milliseconds, and in general, we are able to get something like 13 requests per second from this single UVSGI process that is running Keystone. Honestly speaking, I was playing around with different settings. I was trying to add more workers, force more threads in Keystone from UVSGI, but I wasn't able to get much different numbers. So it was always roughly 13, maybe 15 requests per second, but it wasn't really dramatically different. The funny implementation, the one in Rust. You see here on the graph quite interesting spike. This is just a warm-up for the test, so don't worry about that. But anyway, what we see here, the average latency of 7 milliseconds, which is like from 600 milliseconds, we are going to 7 milliseconds, which is a huge improvement. And actually, the most interesting thing is that we are able to squeeze nearly 1,000 requests per second. So we have here a factor 100 improvement on the throughput and resource utilization just from, let's say, replacing Python with Rust. So technically, on the API latency level, we cannot say, honestly speaking, that we have 100 times performance improvement. It is in general more in the direction of 10 times performance improvement. But the throughput is the one where we have the biggest impact. And also the interesting fact about that, running Python load test, CPUs were nearly idling, and it was simply not possible to utilize resources. While the load test for Rust was keeping all CPUs busy. So actually, and I think every one of you who is paying for resources in the data center would be happy if resources are being used and not simply idling. I went yet another step and actually tried to perform the same load tests on the server, on the server-like environment with 32 AMD cores. And here, Keystone was deployed in the production-like environment. It was running in the container with UVSGI. It was running behind the load balancer. So there were multiple processes in reality even running. So in really like a production-like environment. We see here the average latency of like 160 milliseconds, and this server was capable of getting 190, let's say 200 requests per second, which is good, but which is not as good as the same test if we would be running Rust. Because now we have, again, latency around 12 milliseconds, and we have throughput of 2,500 requests per second. So that's actually where we are keeping all our resources utilized properly. Interesting in my eyes. Now let's have a look. Also, I decided to try to compare performance improvement from the user perspective. Like I'm the regular user and I'm invoking CLI to actually list the users. So what you see here are three tests. The first test is invoking Python OpenStack client and is doing user list operations. Again, we are not looking on absolute numbers, but only on improvement. The operation takes something like 600 milliseconds. And for those of you who at least were partly involved in the challenges with the Python OpenStack client, know that the more dirtier your environment where OpenStack client is deployed, the worse numbers would be. So it's actually incredibly unstable number. But anyway, we have something like 600 milliseconds for listing users. Replacing Python OpenStack client with the Rust client and doing the same operation on the same server, on the same environment. So everything is the same, it's just that we use different client. Takes 100 milliseconds. So we have here improvement, factor 6 improvement already from the user perspective. And the final test is actually showing the same, but if we would be replacing Python Keystone with Rust Keystone, we see here the latency resulting at 15 milliseconds. which is actually, if you are careful enough, you will see that you get the response back faster than the average deviation, that the deviation of the Python test, which is, in my eyes, completely insane. So we have here roughly factor 40 improvement on the latency from the user perspective. I'm a user and I would like to perform some operation, and I have results back 40 times faster. So now demo time. Hopefully everything will work. And before that, few disclaimers. I would be showing also authenticating with the passkeys, or actually not the passkey, but the security key. I would be showing how to get authenticate, how to get Keystone token with YubiKey. So, but again, disclaimer, passkey is not equal to security key. If you talk about passkey, you are not necessarily talking about security key or YubiKey. Your YubiKey is not equal to passkey. Passkey is not equal to passkey. We are talking about that Apple interpretation of passkey is not equal to Android interpretation of passkey, and that is not equal to Windows interpretation of passkey, which is again not equal to simply YubiKey. I spent on that topic quite some time. I was able also to find a very interesting blog post of a maintainer of one SDK for passkey support in Rust. Completely deillusionated, saying most likely passkey will simply fail as a concept because every provider like Apple, Android are pulling again having a fight between each other, trying to reinvent the wheel and have introduced so much deviation into standard. But anyway, let's have a look. So you see my terminal, right? Hopefully, yeah. Let's start the Rust Keystone. So we are on the other terminal where we would like to simply authenticate ourselves. So voila, we have actually authenticated ourselves with a password. So that connection was just a password-based authentication. We see here it took, well, I admit it's a little bit hard to read between lines, but it was something like 200 milliseconds. And again, this is exactly the case where password hashing is invoked. So do not expect that simply having that step done in Rust will give you major performance improvement. Anyway, the point is we were able to authenticate towards Keystone rewritten in Rust. We can do identity user list, and we see all our users wide. And like that, we can do catalog list. So some operations are implemented. I actually do not know identity group list, whether it works. Yeah, that works as well. Perfect. So yeah, this was more or less, honestly speaking, I don't know what to show in live when we just re-implementing existing system. So it's not really so much interesting, but I'm going to show now authenticating with the YubiKey. I assume this is more interesting part, but also here, well, this is just authentication. It's not something really astonishing. Here I need to admit I haven't integrated yet into the OpenStack client because this is a relatively complex process. I don't mean the integration, I mean the authenticating with YubiKey. I will shortly show the short diagram on that, explaining the process, but technically what I mean that there are multiple operations, multiple requests invoked in this workflow. You can see actually on the left side them. But because of that, I'm at the moment not 100% sure that everything will stay exactly this way, or maybe something will change. So I don't want to waste my time before I'm actually convinced on the, so to say, on the API side. So what we are doing is, so I have implemented actually a small helper, which is like which is mimicking OpenStack client for getting authentication. So imagine that this authentication will work like in your Cloud YAML, you will have different OAuth type set to maybe YubiKey, maybe passkey, I don't know yet. And this is exactly why I say that I haven't integrated it yet. But it would be just another authentication type in your Cloud YAML. We invoke the operation, and what it tells me, it asks me to actually enter PIN of my YubiKey. I have inserted it already in my laptop. I'm entering PIN code, and it tells me, please touch your device. I have touched my device, and voila, we see actually the token here. We also have here the helper output just to be able to validate the token. So it's an API call to validate the token with the token itself. So we call it, and we see here, well, the request actually came. We repeat it just to be sure. And yeah, that's it. And now let's actually replace the port to be querying the Python Keystone, and it actually also responds. And we see here that at least issued at is matching. Yeah, it matches, but the format is a little bit different. Okay, need to work on that. But anyway, the point is that I was able to authenticate myself and get Keystone token with YubiKey. Now let's go back and have a look on the diagram. That is a relatively complex thing. It's actually very similar, independent on whether you are trying to register a new passkey or security key device, or you try to authenticate. So first would be the client, which is actually our CLI in that case, but it may be a browser. Is sending a request to the server with the authentication request, and it needs to actually pass data like user XYZ is willing to authenticate himself with some security device. The server responds with the challenge to be that needs to be signed. This challenge is then passed by client to the authenticator, and this is some virtual thing, which is, sorry, depending on whether we are talking about security devices or passkeys, is either that you are passing this challenge to your YubiKey or you are passing it to the browser. Basically, the point is here that if you would like to access passkeys that are stored on the Apple keychain or Android on your Google Wallet, that must be a browser. And there is no way to access those platform-specific passkeys out of the CLI. So I mean, technically, it simply must be a browser. So that is what is making this a little bit more complex. Anyway, once request is reaching the authenticator device, it's actually signing the challenge. Eventually, this is exactly the moment where it tells, please touch the device, please touch your fingerprint scanner, something like that. Once that it's done, the signed challenge is being passed from authenticator back to client. The client sends it back to the server. Server actually verifies that the signature is matching the public key that is stored on the server side. And if it's done, it's just returning back the token. And as I said, the registration of the device is also very, very similar process. It's just more or less renaming the arrows here. Yeah, that's actually it. So let's have a look on the roadmap and things that are in my head right now. So I'm planning to make this, for the moment, I name it Keystone NG, next generation. Yeah, but anyway, make this new component as an additional deployment component, which needs to be really highly integrated with the Rust CLI. And here I again say I'm at the moment not planning to invest any time in adding support for that into Python OpenStack client, because this is exactly the moment. So the whole work is on improving performance. It doesn't really make sense to go back to technologies which are not which will bring you simply back. And on the other side, I'm just willing to raise the user base of the tools that I'm creating. This component should be actually at the moment, at least initially, taking care of those advanced authentication flows. Not only authentication, but federation and authentication. So it needs to be dealing with those customer managed IDP stuff, where users would be able to register their own IDPs that they want to trust, including the authentication workflows with that. We are going to be also adding support for scheme here, this data synchronization stuff, and JVT authentication. Again, what I said previously, you have a GitHub, GitLab workflow, and you would like it to access your cloud. So that is where it should be possible to exchange JWT token with Keystone token. Authenticating with security devices, we have just seen authenticating with YubiKey. So in general, idea is that this new component at certain point in time should be able to overtake authentication and token validation from Keystone, so that CSPs are able to deploy it in parallel, and just in their proxies or load balancers simply replace the backends, saying that all calls for token validation or authorization are handled by the Rust implementation. Everything else what's not implemented yet in Rust, that can still be served by the Python. But you will definitely have here huge performance improvement, because token validation is exactly the operation that is performed most frequently on the Keystone. And again, so next would be closing those functional gaps, adding more and more native things from Keystone in the Rust, so that at some point in time, it should be possible to actually completely put on pension the Python Keystone and have a new and shiny Rust with much better performance numbers. So yeah, link to my Git repository where the project is at the moment placed. We are going to have a discussion on that as well during the PTG, which is like in a couple of weeks within the Keystone team, where generally there is huge support for that. Just we would need to manage certain things also from the technical committee side, that Rust should be allowed. But anyway, the idea is I would like actually to hand over this reimplementation under the foundation. Just we need to solve some bureaucracy questions for the beginning. That's it from me. Now I'm ready to answer questions, and hopefully there are some questions.
Thank you so much, Artem. Very nice talk. I would start because there were some questions that popped up in the chat during your talk. I would start with Niels. You asked, that was the slide where you showed those, I think milliseconds it was. Niels, do you just want to repeat your question instead of me?
Yeah, I was just widely guessing. So I wondered, are those user space or kernel space? Where did you spend those 200 milliseconds?
Well, it depends. There were actually numbers everywhere spent in the user space, in the sys space, in kernel. They are all spread it. And basically the difference is that in Rust implementation, mostly you spend time in the kernel space, in the user space, yeah. While the Python is spending much more on the sys side.
Mm-hmm. So I was speculating that maybe this is one of these just-in-time compiler they built into Python recently. I don't know.
Yeah.
Well,
it also definitely matters which version of Python you are using.
Yeah. So probably not the most important question about the whole project.
Yeah.
Okay, I think Kurt was next.
Thanks, Ariane. Thanks, Artem. Impressive work, first of all.
Thanks.
Which I really appreciate. I think the last time we discussed, there still was like significant opposition inside the OpenStack community to accept anything else than Python, which of course would make some of your work not being able to be integrated upstream, which would be a really pity. Are you making progress with those discussions? Is there anything that you think maybe some people in the community could help with, or maybe even some board directors could help with?
Yeah, I would say I would definitely need some support. Technically, my plan was to raise a little bit of pressure by raising user base, so that I'm introducing better tools. Those start being used by CSPs, by people, and once there is certain user base, there is basically a weight to the voice saying we want to have it approved. Within the Keystone team, there is definitely support for rewriting it in Rust. There is absolutely zero opposition. So it's actually more exactly on this technical committee side. I was actually, the last time I was talking about that was, I think 1 year ago, and I was honestly speaking not really very happy with feedback of some people that we are trying to simply block that because they wouldn't be able to support the project if something happens. But on the other side, I was raising nearly the question, wait a second, but you are not supporting me right now, so what's the difference? So it's like a little bit of bureaucracy stuff, and having support from the community or from the directors board would be definitely welcome here.
So how many lines of code are we talking about here in the overall Keystone?
I don't know at the moment. I would say roughly something like 100,000.
And how much does the current implementation cover?
Oh, just a little bit. I'm roughly talking. My expectation would be 100,000 in total. It would be, and at the moment it is something like maybe 5,000 to 10,000 lines of code.
Okay. So more or less 10% done.
Yeah, in Keystone there are so many things under the hood that actually nobody knows. That finding those out, that's exactly one of those problematic things that I also figured out. Some things that actually no one knew, no one in the Keystone team was ever aware that things like that exist.
At least not in the past 8 years or so.
Yeah.
Well, maybe opportunity to get rid of things as well then.
Yeah, sure. That is also definitely a moment that I'm not willing, I'm not planning to re-implement things that were marked as deprecated or that make just historically no sense anymore. So I'm not going to have 100% coverage from the current Keystone. It's not the purpose, I think. It's not the goal.
Okay, I have one more architectural question. Maybe you have explained that already, but just to confirm that I understood it correctly. So your Keystone NG it's possible to run your Keystone NG next to the classic one to be free or something like that. And you can decide on your configuration or the service catalog, how you access the service catalog, which one to use for which use case, right?
Something like that. It's more, however, not on the service catalog side, but on the proxy configuration, because we are not talking about introducing a new service. We are talking about delegating certain API calls from that service to the other location. So it's like more adding a new backend into your load balancer config and only routing certain API calls to a new backend.
Okay, got it. So that would mean that you are not touching the Keystone API at all. So I mean, there will Keystone v3 will stay.
Yeah,
it's
sure.
not affected by that.
Yeah, and what I mentioned at the very beginning, there is possibility to actually implement a proxying on the new Keystone, so that you would be able to actually place it in the front and be able to delegate to the Python Keystone if the call is not supported. But that's not implemented at the moment.
Okay, now got it. Yeah, impressive.
Thanks.
You have too much time.
No,
you must be
not
bored.
at all. Not at all.
To take over Keystone. Yeah.
Yeah, some people wonder that only now. I thought you would be doing that already earlier, like 1 year earlier.
Indeed.
Okay, Matthias Kant is also raised, I see.
Yeah, thanks. Okay, it seems you can hear me. That's good.
Yep.
So first of all, yeah, impressive work, and I really like what you're doing. But I decided to ask some nasty, annoying questions for some kind of executive summary. I think it would be good if you could not only compare your great Rust implementation to the existing Python implementation, but also say what, let's say, an optimal Python implementation could do, just to have maybe some kind of justification for not just re-implementing it, but also re-implementing it in another language. Just some rough numbers, you know. I don't know how hard it is to estimate that.
Well, rough numbers.
First of 3 questions that I have.
I mentioned that roughly you have 40 times up to 100 times better throughput. Well, this is already a statement on its own. You have
so
roughly.
This is also compared to an optimal Python implementation.
Yeah, to compare to optimized, to highly optimized one.
Okay.
So not at all optimized Rust compared to highly optimized Python would be 40 to 100 times. Well, and again, I need to say here that there is a difference whether we are comparing API latency, basically response duration, or whether we are comparing the throughput on the server side. So with latency improved, I would say roughly in average, everything else, all the corner cases that I was investigating. So roughly on the latency, you have 10 times better latency, but you have at the same time something like 100 times more throughput from the single process on the server side.
Okay, yeah, sorry, maybe I missed that earlier, that you were comparing to the optimized Python. But also this leads the throughput thing, I think, leads to my second and third question. This would be, what would be the impact in a real world scenario, for example, where people are using complex Terraform scripts and stuff like that? And for example, if you have a production setup, could you really have some savings, like use fewer cores or fewer nodes for handling this kind of stuff with your optimized Keystone?
Yeah, I hate to interrupt this. I can give you like 1 more minute, and then we have to jump over to some community announcements. So yeah, we can take this last minute. So I'm sorry.
No problem. Okay, Matthias, we can talk also afterwards about that. I think that the biggest improvement you will get not on the user side, it's more on the CSP side. Technically, with that step, you would be able eventually to get rid of certain amount of servers. As you have seen, you have like 100 times better throughput, and on the 32 core server, basically you have like 2,500 requests per second on the same server, as you would have only 200 requests per second with Python implementation. So eventually you would be able to save some servers and reduce your costs.
Thanks.
Okay. Well, thank you for this wonderful talk and this very vivid discussion. I'm sure there will be opportunities to continue those talks afterwards. If you don't mind, I would briefly hop for the last 5 minutes. Wait, where is the screen sharing? There it is. To some announcement. Again, Artem, thank you so much. This was really amazing. Where are we? We are here. Yes, because there's always some news and events looking back on what has happened. Just this week, we were in Berlin and we had an Alaska roundtable that had the topic continuity on the path to digital sovereignty, European initiatives in the focus. I don't think we have that much time for a recap. I know there are some people here who attended this. Maybe someone wants to give a brief statement. I've heard that it was really a successful event. But otherwise, I know that the results of those discussions will be published very soon on our LinkedIn, on our website, and also a white paper is being worked out. So you can read all of that later on. Then we have been at the FOSS backstage also, March 10th and 11th in Berlin, where we talked about how we built Alaska from scratch by choosing this foundation-backed approach for YAUK. So way back then, it's also a very, very nice session with lots of interesting discussions, especially with other foundations. And then we also had a nice community meetup at the CloudFest with many members from the community, where we also got an update from our technical steering committee. There is a lot going on there too, so this is very nice. Before I hop over to an announcement, is there anything else anyone would like to share from their community? Anything interesting that has happened or is going to happen? If not, you are all very welcome to mark your calendars, because we can now announce the date for our next Alaska Summit. It will be November 3rd and 4th in Dresden again. We are doing this year again in Alaska's hometown. Same location as last year, Deutsches Hygienemuseum. So this is your friendly save the date call to action. Call for presentations and more infos on registration, and everything is coming very soon. We will keep you posted on that. And I would end this. Wait, is there something going on? Oh yes, there have been events posted in the chat. I see the SCS hackathon coming up. Kurt or Felix, do you want to say something on that?
I just had to look for the unmute.
Yes.
The next SCS hackathon is happening on the 29th and 30th of April, which is in a month. So please come to Erlangen. We're at the RZE of the FAU University, and there's the only still working the Z23 there. So it's also a reason to go there. And also the next SCS Summit is going to be on the 24th of September. So mark your calendars for that as well. Yeah, that's just some highlight there.
Thank you. Thank you for sharing that. And if there is nothing else, I would announce the Tech Talk for April within the last minute. Let me hop over. So yes, ALASCA Tech-Talk number, I think 24 it is April 25th, usual time. And we have Pacifical Digital Exploration, as our guest, who will share the talk on low code for developers, creating scalable UIs for your CLI tools. And the very nice thing is that they will do a demonstration on that with Krake, which is our open source tool for workload orchestration that is being developed in Alaska. So this will be a very nice talk. We are looking towards to that very much. And with that, I'm wishing you all a very amazing weekend. Artem, thank you so much for taking your time to be here. It was a very fantastic talk. And yeah, wishing everyone a nice day, and see you next time.